Okay, this will be the first video on section P-2, which is on exponents and radicals, but this particular video will only be on exponents, and we will be reviewing a couple of things about exponents. We will be reviewing the rules or laws of exponents, and then we will be reviewing how to evaluate and simplify exponents. Okay, all of this should be ringing a bell because you should have talked about most of the basic rules of or laws of exponents in Algebra 1 and continued with evaluating and simplifying, because to evaluate and simplify you are simply using the rules or laws of exponents. I will talk about the rules as I go through a couple of examples. However, on page 13 in your textbook, at the bottom is a chart with all of the rules. On the left-hand side, it has an example with a variable of what the rule says to do. And on the right-hand side is an actual example with numbers of what to do. So we have, it looks like 8 different properties of exponents, or rules or laws as I was calling them. So we will be using those. So for example, property 1, when you multiply, so here's property 1. I know you probably can't see it on my video, but you should be able to look at it in your book. Property 1, when you multiply two exponents with the same base, you add the exponents. Okay? And I think an important thing to remember here is a lot of these rules apply to things that have the same base. So you just need to be checking and making sure whether you have same base or different bases. Okay, so my first 2 examples would be evaluating the expression. And we've got 5 to the 5th power being divided by 5 squared. Now, I want to evaluate. The reason why I'm using the word evaluate is because I should be able to come up with an answer. So evaluate the expression 5 to the 5th divided by 5 squared. Now I could get out my calculator and figure out what 5 to the 5th is, and then 5 squared, you should know, is 25, and then divide the 2. But I can use one of my laws, which says that if I am dividing two exponents with the same base, that I can subtract the exponents. So really, this is 5 to the 3rd. Now again, you're evaluating, so you should have an answer. So that would be 125. Second example. 3 squared divided by 3 to the 4th. Again, you are dividing two exponents with the same base. So I can use the previous rule that I used, the base being my 3. So I can do 3 to the 2 minus 4, and I'm going to end up with 3 to the negative 2. Another one of your laws is that you should not have any negative exponents, and in order to make that not a negative exponent, you write it as its reciprocal, and then we don't have our negative. So this is going to become 1 over 3 squared. That's its reciprocal, because technically This over here is 3 to the negative 2 over 1. So its reciprocal is 1 over 3 to the positive 2. And now all I need to do is, I don't want to actually leave an exponent, so 1 over 3 squared would be 1 over 9. So that would be evaluating. You have an actual answer. The second piece would be simplify the expression. You use simplify because now you won't have a numerical answer. So I've got 4y raised to the negative 2 and 8y raised to the 4th power. So here, the 4 and the 8 are going to go ahead and be multiplied together. So we've got 32. And here I am multiplying exponents with the same base. So instead of subtracting them, I go ahead and add. So I'd have y to the negative 2 plus 4. So really this is 32y to the 2nd power. Now remember, it is possible for you to have things that don't have the same power. So last example in this video, we've got 8x to the negative 3, y to the 4th being divided by 5, all that to the negative 3. Okay. So there are lots of different ways you can go about this, but the first thing I'm going to do is when you have an exponent raised to a power, this needs to get distributed to every exponent, and they are multiplied. So this would be x to the 9th, because negative 3 times my negative 3 out here. Then I've got 4 times negative 3, so y to the negative 12. My 5 has an exponent of 1, so that would be 5 to the negative 3. Okay, now I don't see x and y do not have the same base, so I can't combine those. 5 does not have the same base. So I can't simplify anything other than I need to not leave any negative exponents. So x to the 9th is okay. The reciprocal of y to the negative 12 would be 1 over y to the 12. So that is why y to the 12th would go in the denominator. And 5 to the negative 3 should go in the numerator and should become 5 to the 3rd. And the only other thing you could do to simplify this expression would be to go ahead and figure out what 5 to the 3rd is. So we should have 125 x to the 9th over y to the 12th. So these are the types of problems you're going to be encountering as far as rules of exponents and laws of exponents.